Today we're going to be introducing stoichiometry. So what is stoichiometry? Stoichiometry is the study of quantitative relationships between the amounts of reactants used and the products formed in a chemical reaction. It is based on the law of conservation of mass. So what is the law of conservation of mass? Yes, that's right. It is the law that states that matter is neither created nor destroyed in a chemical reaction. So basically, in a chemical reaction, the mass of the reactants will equal the mass of products, which is a main point in stoichiometry. So how are products created if the law of conservation must be followed? That's correct. Bonds will break and atoms will be rearranged and new bonds will form to create new molecules. So next we're going to watch a video introducing stoichiometry where they'll use an example on using grilled cheese. The video is 3 minutes long and I will not be playing it for this video clip. So why are we learning about stoichiometry? Now that we know the what, we can focus on the why. It is important to know why we need it so that we can place a certain amount of importance on the subject. For chemistry, such as in this class, it is a fundamental topic that is used in most aspects of chemistry. It is used to make useful predictions about chemical reactions. So basically, you can use it to predict the amount of products you will get or the amount of reactants you will need to get a certain amount of products. Like we saw in the video, it asked us about how many pieces of bread will we need to make 7 full grilled cheese? The answer was 14, and we used stoichiometry to get there. As a career path, pharmacists use stoichiometry to mix some medications, and they need to understand the medications that they give to those who need it, and they use stoichiometry to do so. Scientists use stoichiometry to reduce the cost of buying chemicals as well as the amount of waste they have. In our everyday lives, the basic idea of stoichiometry is used in cooking, converting between units like Fahrenheit or Celsius, and knowing how much fertilizer to use in the garden, and other things like that. So the mole ratio is an important aspect of stoichiometry. The mole ratio is the ratio between the numbers of moles of any two substances in a balanced chemical equation. So it can be between products, it can be between reactants, and it can be between reactants and products. So here's an example on how we're going to make aluminum bromide. We need aluminum, bromine. So how many moles do we need to make this a balanced equation? Can anyone guess? Or not guess, but tell me. Yes, we need 2 moles of aluminum, 3 moles of bromide to make 2 moles of aluminum bromine. So the mole ratio for aluminum and bromine is 2 moles of aluminum to 3 moles of bromine. The mole ratio for aluminum to aluminum bromide is 2 moles of aluminum to 2 moles of aluminum bromide. So what other mole ratios can we make using this chemical reaction? That's correct, there's 4. Can anyone name them? You got some of them right. So we have bromine to aluminum, bromine to aluminum bromide, aluminum bromide to aluminum, and aluminum bromide to bromine. So you can go from reactants to products or products to reactants. So these are the steps you need to do to use stoichiometry. First, you need a balanced equation. Then you need to identify the known and unknown, such as, do we know how much of the reactant we have? Do we know how much product we want? Do we know the moles, or do we know the molar mass? Knowing if we're using moles and grams is also an important part. So we need to know our conversion factors. So there's the mole ratio, which is moles to moles. There's molar mass, which is moles to grams, and vice versa. There's molarity, which is moles to liters of a solution, so it must be liquid. And then there's molar volume, which is moles to liters of gas. And then you need to just check your answer when you're done. So next we're going to do an example problem on how to use stoichiometry.